Initial challenge the reversal maximum volts destroyed by robots. Again, the task with robots. Basically, given robots distances, the maximum distance robot bullets can travel, and by given volts, it should return the maximum number of unique volts that can be destroyed by the robots here. So basically, it's integer answer here. Start our implementation. We're gonna sort the first iteration, zip robots distance, lists arrays. So we got the positions for position in pairs, and distance is distance for distance in pairs. We're gonna sort our vols, and we need some helper method to count actual number. So we're gonna use the bisect, import some solutions here. So count left, right, and return bisect right of vols are minus bisect left and vols, and we're getting the length as usual of the positions. Amount of left count is 0 multiplied by n, and right count the same. The first iteration we're gonna compute the ranges here. So left one is position I minus distance I. If the count I is equal to count L position I. So we calculated the left position and started with right one. So going to the right, so if I is lower than n minus I, which is boundary, so we assign our right count I is assigned to new value, which is count of position I, right one. In the next step, we're gonna use the dynamic programming approach, going to the left and going to the right. So left count is 0 initially, and right one is right count 0 element. We're gonna iterate until n, which is amount of positions in for I in range 1 until n. Now we're trying to implement. So first of all, we're shooting left and calculating new left basically, which is dp left dp right plus left count I. Then we try shooting left, so let's make it the first case. Let's make it the second one. So we're shooting right now. So option 1 is dp left plus right count I. Second one case, we're gonna shoot right, but subtract the overlap since it may exist. So in the first case, we didn't count the overlap. So overlap L is plus I, overlap R is minimum of position I plus distance I, and position I minus 1 plus distance I minus 1. If overlap of L is lower than overlap R, in this case overlap is count of overlap LR. Let's copy these ones here. And the second option, option 2, is dp right plus right count I minus overlap. So we're subtracting, and new right is maximum of both options. Let's take option 1, option 2. And dp left and right are assigned to a new one. So new left, new right here. And result is basically the maximum of these both. So let's try submitting a solution to see if it actually counts passes. So after adjusting the solution here, we'll use the dp array now and calculating the maximum of the current one, so the new one. So let's try resubmitting it actually to see if it actually works now. So thank you guys for watching. See you next day.